All right. So what I want to do is finish what was covered in chapter 2, but I want to go back to Minitab for a second and screen share it. So you'll let me know whether you can see it. I'm pretty sure you can see it. Um, all right, you're good? You could see it?
Yep.
Yes.
All right. All right, anyway. So I have several tabs here on the Minitab workbook here, or project book, I guess they call it. And so I just want to go over. Now, the thing about the histogram, I was playing around with Excel today, and Excel does have the ability to create a histogram, all right? And you can choose the number of bins and all of that. But again, I have Office 365, the most recent version of Office. You may have a earlier version of Excel. So for me to show you what I have in Excel may not match what you have, unless you all have 365. Do you all have Office 365? Actually, you know what? If you're using Mac, I guess they have a different Office, right? Microsoft Office.
I mean, it's possibly different, but I'm not sure which version I have. I have Microsoft Excel for Mac, license 365, so it should be the same.
Right. Okay. Well, there's. I mean, I can open it up. Again, I don't know if it's similar, but maybe I should do that instead of looking at this. I did create an Excel spreadsheet for this. How about the rest of you? Do you have 365? Yeah, Han has it. How about you, Mo? Do you have 365? No, I can't hear you because your video, your audio is off. Yeah.
Yes, sorry. I believe I do. I downloaded it through the school's program, so I think that I automatically got 365.
All right, good. So if you have 365, maybe what I should do is open up Excel. I'm going to do that for a second, and then let's see. You. You won't see it for a second. I just want to make sure I have the right one here. Yeah, this is it. All right. All right, so let me share that with you. All right, so this is the Excel spreadsheet. I created everything pretty much what I created in Minitab here. Of course, you know, you have to use formulas and all that sort of thing. I had to play with it a little bit because Excel does histograms a little bit differently. If you have an interval, it tends to include the ending value, but not the beginning value. Yes, they do it. It does it backwards from. You see what I'm saying? So you have to play with it to get it to match what's in Minitab. Well, what I did was I just created my intervals like I did in Minitab, the same thing. I had a formula here for number of bins. I rounded it. I used the rounding thing here. Bin width, I rounded up, which is what you should do. You round up to the nearest whole number. So I got number of bins 8, the bin width 6. And then I created separate columns for the lower value in a class and the upper value. And then I did what I did before. And actually here, there's a function in Excel called frequency. And so the first array here, A2 to A106, is the data. So you don't actually have to order it in Excel because it has this frequency function. So the first A2 to A106 is the data set. Then E2 to E8 is the bin values. Um, wait a minute. Yeah, the bin values. And notice what I used, because Excel does it kind of weirdly. If you list these bin values, the very first one, it's going to take less than or equal to that value. And the very last one, it's going to be greater than that value. All right. It automatically does that. I don't know if there's a way around that. So, and then I picked 50.9 to 56.9 instead of 51 to 56.9, because what it's doing in Excel is it's it's not including the beginning value here. All right. So I'm picking 50.9 to 56.9. And so it's values that are bigger than 50.9, but less than or equal to 56.9. All right. Does that sort of make sense? Again, it does it backwards. So I didn't realize it until I was actually doing it that it does that. But I had to do that to get the frequencies to match what's in Minitab.
Mm-hmm.
All right. So I just copied the formula all the way down. So this one, the next one would be, well, this is for the whole thing here, whole thing. And I did E2. I started with 50.9, which is the, which allowed me to do this less than or equal to 50.9. And then I ran it up to E8, which was this number here, 86.9. And the last one's going to be greater than that number. You see what I'm saying?
Mm-hmm.
I hope you do. Again, I had to play with it to make this work. So I'm gonna, if you want, I'll post this also. And I'm not restricting you. You can look at the formulas and all and see if you can figure it out. But that's how I did it, and it created the same. It created this the 8 bars and the same. And if you just put your cursor over it, it gives you the value, right? 14. The first one is going to be 1 or 2. There's 2 in the first class, right? And then there's 14 in the second. If you just run your cursor over it, it gives you the height of each one of these. Okay? And it does match Minitab. All right, and then of course, once I have the frequencies, I did the relative frequencies by using the formula. This divided, each one of these divided by 105. All right, and I'm assuming all of you know how to use Excel. You know when to use the dollar sign and all to fix the position of a formula. You know about that in Excel, the dollar sign.
I've used formulas plenty. I've never used the dollar sign, but I'm sure I could learn.
Yeah, well, maybe I should bring it to your attention. What the dollar sign does is it fixes the. You can put a dollar sign before the F, or you can put it before the 10 here. And what it does by putting it before the 10, as you move the formula down, it keeps the 10 there.
Oh, so, I see. Okay.
See, normally it's relative, right? So if you copy a formula down, the next one should be 11, right?
Yeah.
11 and 12 to keep it. But I'm interested in dividing each of these by 105. 105 is in a fixed position. So the fixed position, you put a dollar sign before the 10. Now, if the formula makes the column change and you want to keep the column the same, fixed, you put a dollar sign before the F.
Mm.
In this case, it wouldn't have made any difference because everything is with reference to column F. Okay.
Yep.
But if you wanted to fix the column, you put a dollar sign before the letter. And sometimes you want to do both. In this case, the only one you wanted to fix is the 10 because position or row 10 is where the 105 is. And you want to divide each of these numbers by 105. And that's why you put the dollar sign in there. So when you create your formula in the first formula, make sure you go back and put the dollar sign in there before you copy it. Okay, that's been in Excel for years. I mean, I think since the beginning is this dollar sign thing. All right, so that's the relative frequencies. And of course, I formatted it. I just right-click G here and click Format Cells, and then pick 3 for the, yeah, I guess you all know how to do that. Cumulative frequency is simply, you can, in Excel, you can create a formula for this. So you put in the very first one, just say it's equal to F2, for example, this first one. And then this one is going to be H2, the previous value of the cumulative frequency plus the frequency for that row. And that gives me the cumulative frequency. And then if you copy that formula down, you get all the rest of them. That make sense?
Yep.
Okay. Cumulative relative frequency, the same thing. Just say this one's equal to G2, and then this one's going to be equal to I2 plus G3. And then copy that formula down, and you get all the rest of them. Now the midpoint, now remember I had to fiddle with this, and instead of saying it was 45, saying the class boundaries was 45 to 51, I had to make this 50.9 to make this histogram thing work. But to get the midpoint, you really should be averaging 45 and 51, which is 48. So in my average formula here, I just added 0.1 to the value in E2. So it came out nice and clean, okay? And so it's just the average of those lower and upper values. And that's where I got the midpoint. All right, so I'll post this and take a look. And Han, Han, you're using Minitab for the histogram, just like I use it, but you can look at this too if you want. Everyone else who's using Mac, the histogram's not working very well, so you can do it here. So I figured hopefully there's not too many of these graphs where you're going to where there's a big discrepancy between the PC and Mac versions of Minitab. All right. So this is one case where I gave you a way of doing it in Excel, so you don't have to do it in Minitab. All right. Any questions about that? So yeah, so that's it. And all right, so let's go back to Minitab. Now, the other thing I wanted to mention, in the book, it talks about a line chart, and I believe the Mac version doesn't even have a line chart at all, and the Minitab does. So I'm skipping the line chart. It's not even part of it. It's not necessary to use. So I'm going to skip that altogether. All right. So let's go back to Minitab. All right, so let me get to this here. And this is this tab here I have, and I will post this project for you, project file. But the histogram is based off of this here, all of this, right? Similar to what we did in Excel just a minute ago, except we're using the calc feature to calculate this stuff here. The number of bins, notice I have 8 here. That's because I rounded up. I rounded. It was before it was said 7.7 something, the number of bins, and I just used the round feature. Actually, if you go into calc, let me just do that C4. If you actually just type C4 here, it should, yeah, it just brings up the formula that I created. Notice I used round, which is, they don't have round up, by the way, in here. They just have round. There's the round one there. It's a round function. So I put it, and then put the formula inside, and it rounded up, and it rounded to 8, because it was 7.7 something. All right. I actually calculated the range, which was just the minimum minus the maximum, maximum minus the minimum. Bin width, of course, is calculated the same as before, but because they don't have a round up function, I just rounded up myself. So I want you for the bin width, which is the range divided by the number of bins, whatever you get here, just round up to the next whole number. Even if this comes out to a whole number, round up to the next whole number, all right? So that's where I got 6 here. I just typed it in. Here are the classes. It's the same as before. Here are the frequencies. Remember, we had to do this manually, right? I had to sort, and then we had to count them. So that's how we got this. Relative frequency, same thing as we did before. Each of these numbers divide by 105. Use 3 decimal places. Cumulative frequencies. Did this manually, right? Yeah. I don't know how the formula is going to work for doing it. So I just did it manually. It's easy enough. Cumulative frequencies I did manually. The midpoints I also did manually. All right. And you could tell what the midpoints are, right? The difference between these two values, the midpoint basically is the bin width, 6. If you divide it by 2 and add it to the first number, that gives you the midpoint. You take half the width, add it to the beginning value, and it's another way of calculating the midpoint. So I just did it in my head. All right. So, and then to create the histogram, we just used histogram, right? I mean, Han, you're the only one here tonight who could do it this way. And you know how we did this, right? Han, you remember how we created the histogram?
From graph?
Yes. And how we ended up with the 8 here? Remember how we did it?
Oh, right. Yes.
You remember that? Okay. All right. I just wanted to make sure that you remembered how to do that. All right. Because we used graph, and then we chose histogram. We chose it, and then we went into. Well, maybe I should do it again. Let's just do it one more time. We went OK, and then we did speed here, and what we went into, not here.
Yeah.
Right? It wasn't here that we could do it. Although I think you could do it from here. You see scale, live scale. Now, you can only choose the type here, right? Frequency versus percent. So you had to create it, and then once you created it, you edit it, right? And then you click the numbers down here, and you create the number, you create the bins, right? What the bins are. Yeah. All right, so that's how you create it in Minitab. All right, and that's it for just a quick review of the histogram. All right. Now, the next one is stem and leaf. Now, all of you should be able to do stem and leaf. I think stem and leaf is a graph that's in the Mac version also. And I didn't do anything. So all the rest of these graphs here, I didn't make any choices. I think that all of you should be able to recreate what I've created here, but you'll have to let me know this. Now, I posted all of the Excel files that I've used here. I posted those in Canvas. Now, the histogram, the stem and leaf, and the dot plot all use the same speed Excel file, one on speed. All right. So the one that you've used to create, we're trying to create the histogram, you will also use for the stem and leaf and the dot plot. All right, so same speed data set in stem and leaf. And this is what the stem and leaf looks like. Have you all read the chapter 2 on stem and leaf? Have you read it?
Yes.
All right. So you know how it works, where there's now this thing right here, these numbers right here have something to do with the number of values over here. I would ignore this. I don't know how to get rid of this. This is really annoying. I don't know. I think the many tab people thought this would be useful, but I don't know. When I first saw it, kind of wasn't sure what it was. These numbers in the middle here represent the stem, and these numbers over here represent the leaf, I think. This is 54.2. I think that's the way it works, but let me double check that. I think the decimal part of it is dropped when they did this. All right, decimal part is dropped. Because the smallest value in the data set is what? What is it again? 48.4. So here's 48 right here, and it just drops the decimal part of it. The decimal is not really needed. And the reason why it's not needed is because the purpose of the stem and leaf is to give you the shape of the distribution of numbers. If you drew a curve around this shape here, right? You drew a curve around it, and if the picture just rotating it 90 degrees counterclockwise, all right, this could look like a histogram, right?
Mm-hmm.
Instead of the numbers here, you'd have bars, right? The value of the stem and leaf is that you can actually see the numbers. So here's 48, here's 50, 51, 52, there's two 52s, 53, and so forth. All right. Again, we're dropping the decimal part of it. And we're just looking at, so these are the tens position, and these are the ones position. And the decimal position is dropped. And the idea is just to look at the shape of the distribution. Look at the shape of it. Looks pretty symmetrical, doesn't it?
Yeah.
Yeah. So that's stem and leaf. Now, stem and leaf is not very useful if you have a very large data set, because it's just too many numbers. All right, it gets so, numbers get so small you can't see it anymore. So stem and leaf is pretty much only used in a introductory statistics class. I've never seen anybody use a stem and leaf in real research. They usually use a histogram because they're just interested in the shape of the distribution. So a histogram does that nicely. All right, but if you were going to do this by hand, ordering the data set would be helpful, and then you just go down and list the tens position here. Now, why do they have 5 and 5 here? Because there's so many values, there's so many numbers that are in the 50s that they decided to split it so that any numbers, any ones positions that were from 0 to 4 would go here, and any ones positions that are from 5 to 9 go here. All right, so we have 50, we have 51, all the way up to 54. And in this row here, we have 55, 55, a bunch of 56s, 57s, 58s, and a 59, okay? So if there's a great deal of values in one of these, for one of these stems, sometimes you split the stem into more than one row. Same thing with the 6s, there's even more of those, right? Lots of those. So again, splitting from 0 to 4 for the leaves, and 5 to 9 for the next row. Same thing with the 7s. The 8s did the same thing. Although I don't think they needed to do it with the 8s. They simply could have kept the 8s as one row. There's only one down here, right? there's only an 88, one value between
Yeah.
5 and 9. They might as well put it here because they did the same thing with the 4s here. They only have one. So I don't really see why they need 2 here, but this is a default setting here. This is what you get by default. And I think if you go up to graph and choose stem and leaf, you should see something like this, right? And there's not much else that it does. And I believe the Mac version probably does the same thing. There's nothing, there's no choices here. So I think do you have it in your mini tab in the Mac version, the stem and leaf? Is it there?
We
Yeah.
do, but the format for organizing it is different is all.
I mean, you're saying it came up with something different as a result?
Just the input box, like it's asking for the Y variables and the group variables and the increment.
For stem and leaf?
Yeah, I thought
That's
that was a bit confusing as well.
Really? Steve, you're
Yeah.
getting the same thing? You're getting all that stuff?
Yeah,
So-
there's a field for y variables. I just put speed in there, and then there's one that says group variable, which I'm actually not really sure what you put in there. And then
Well, that's what the
checkbox for
variable.
trim outliers.
Well, that's what the by variable is. If you look on my screen, group and by mean the same thing. It says by variable.
Okay.
That's the same thing as grouping.
Right. So if you wanted to put something in there, what would you put in there?
Only, well, if you had a data set, let's say for gender, you had male, female, and you wanted to have a stem and leaf for each one of them. You could, and there was a variable
I
for
see.
men,
Okay.
for gender. It would group them by, and you could put the gender in here, it would group it by that. We don't have any grouping by speed here. But I mean, if we
Okay.
wanted to,
Okay.
if we wanted, let's say a speed, we could have created 2 groupings of speeds, right? One group less than 60 miles an hour and another grouping greater than 60 miles an hour. And then have a, some sort of value for each one of those. One, maybe 1 or a 2 or 0 and 1. Then we could group it
Okay.
by that variable, and we would have 2 separate stem and leaves, one for each. And you can do a side-by-side comparison.
It looks like the graph turns out exactly the same as the professor's if you just fill out the Y variable as being speed.
Yes.
Okay. Did you put what value did you put for increment?
Nothing. You could just leave that part blank.
Okay. All right. I put in 6 to match what we had done before. All right. Yeah. Now it looks the same.
Yeah, I mean, there is a help button here which would tell you what increment is, what they're asking, what that does. I'm not really sure, but let me just take a quick look. Increment. Enter a number to control vertical scaling by setting the increment between display lines. So maybe they give an example of that. No, they don't give an example of that. I would probably have to call them. I'm not really sure. All right, no biggie. All right, I think we lost the share, right? Did I lose the sharing? Yeah.
No, I still see your screen.
Yeah, but we missed.
Your screen is frozen on our side is all.
Yeah,
Oh.
yeah. Hold on 1 second here. I don't want to get rid of that. I don't know what happened there. All right. Give me a second here. Oh, I'll just stop share. All right, let's just share again. All right, let's go back to the mini tab. All right, but anyway, stem and leaf is very easy, right? Nothing to it. If you're going to do it by hand, again, you'd have option about how to display it, right? But notice in this case, because there's decimals, they drop the decimals. That's typically what you do. Unless the numbers are really small, like they're all decimals, right? So less than 1, then you'd have to make a choice of what the stem is and what the leaf is. But in this case, the program does it for you. All right. Don't want to spend a whole lot of time on stem and leaf. Dot plot. Oops. Again, the same data set. And you go into dot plot, you do graph and dot plot. Just choose the simple one. And it's pretty much the same thing. I'm assuming you don't have all these options here, like scale and all this other stuff, right? Is that correct?
We don't.
Right. So you just click OK, and you'll get what I get, right?
Yep.
This here. That's fine. That's fine. I didn't choose any options, knowing that you probably don't have the options there. All right. So that's pretty easy, and it's basically the way this dot plot works is it takes the individual values in your data set, and I think in this particular case it's also dropping the decimal part of it. All right. Otherwise, it's going to be too much here. Dot plots are also used for small data sets. So it's basically dropping the decimals and looking at the numbers and the tens and the ones, and any numbers that have the same 10 and 1 position, that is like a 54. Notice 54 has 3 dots above it. There's 3 numbers that start with 54 in a data set. You just stack the dots. That tells you the number there. And 55 is going to have 4 numbers: 56, 3, 57, 58, 59, 60, like that. All right. And there's some gaps in here, right? There's a number that starts with 48. And then there's another number here. Let's see, what's that? 53, 52, 51 is the next one. Or actually what they're doing, yeah, 51. So they're rounding. Looks like they're rounding, doesn't it? It's smallest, the next number is 50.5, or is it 51.5? 51.7. 51.7. All right, so it's just, I think it's just dropping the 50.8, 48.4, and then 50.8. 53, 52, 51. No, it looks like they are rounding. So they're not just dropping the decimals in the dot plot, they're rounding, right? Because the 50.8 takes you to 51, and this is 53, 52, 51. So that's what they're doing. They're rounding the numbers to the nearest whole number. All right. But it's a display just like the others where you could see the shape of the distribution. This one looks like 2 what we will call modes, which is the highest point, right? There's one here, there's another one right here. Okay. Looks like a bridge almost, right? Kind of a bridge shape. All right, so again, it's just to display the shape of the distribution. All right, dot plots, again, not used that often because data sets in today's world are much larger. And again, dot plots are not very useful for large data sets. All right, but you need to be familiar with them. Histogram, we have the histogram. Again, let's look at a histogram. This is definitely used in statistics everywhere. Everybody uses these. Now, does this look like it's bell-shaped? Well, sort of and not sort of, right?
Kind of roughly.
What's that? Roughly.
Yeah.
When you look at the stem and leaf, looks more bell-shaped. Dot plot, not so much, right? Not so much. But I'm telling you that the histogram is the one that's used the most. This is the one that people tend to use. And I think it's a reasonable number of bins that we used here. So I think this shape here is pretty much what we would go with. All right. Let's see. Now the next one is, now these are the three main quantitative graphs. The histogram, stem and leaf, and the dot plot are the three main ones that you need to be familiar with. And then for the qualitative ones, bar chart and the pie chart are the main ones we're going to focus on, not the line chart, again, because Minitab for Mac doesn't even have a line chart. So we'll focus on these two, bar chart and the pie chart. Now there's a different file for this. This is what the file looks like when you open up the Excel file. I think it's SPD. I believe SPD could be the might be the one, the Excel file. You see the ones that are, unfortunately, they don't tell us what the file is here, which is very unfortunate because most programs will tell you the file that you use to open it up, and I don't see that here. That kind of gets lost. Let me just check. Hold on one second. I'm just going to go to Excel just for a second here. And take a look at what the files are. Are you seeing what I'm doing or not really? You're not seeing this, right? You're still on the.
I still see Minitab.
Yeah, good. All right. I don't want you seeing what I'm doing.
I think it's the air.
Yeah, just hold on one second. Air, that's right. Air. You're right. That's the one. So I gave you one that's CX02 air. That's this one. Okay. So I'll get back to the Minitab. So that's what this is when you now in the book, this column here, number in thousands, is in C2, not C3. That's a little bit different than what's in the book, but just realize it's in C3 instead of C2. All right, so what we're going to do is do the bar chart. And again, graph and bar chart down here. And if you choose the simple one, and you put in your categorical variable, right? Categorical variable. You have the same choice on your Mac, categorical variable?
Yes.
Right, that's certificate type, right? That's the category, right? And it has four different values: student, private, commercial, and transport. And then the once you type that in, well, not type it in. Once you select it, okay, and then click OK. I think it automatically looks for that other column. Okay, it automatically does that. Right, when you do it, you click OK. You get the book. You get this. You get a bar chart, right? You should get something that looks like this. Where's my bar chart? I guess that's it. It should look like that. Is that right?
Mine does not. Mo, what does yours look like?
What, your bar chart? Tell me what you see when you open up bar chart.
Are you speaking to me? Sorry, you cut out.
Oh, one thing. Yeah, I forgot. Bars represent what you need to choose up here is values from a table.
Oh, okay.
Values from a table. This is a table, right? So values from a table. And then when you choose simple, click OK. Then you get the graph variable, which is the number in thousands, and then the categorical variable. So when you choose C3 here, and then when you click down here, you have C1, which is the categorical, right? And then click OK, and then you should get this. Is that right? Is that what you got?
Yeah.
Okay. Typical bar chart. A bar chart is different than a histogram because the x-axis are categories and not numerical values. All right. So we have categories, and it's basically along the y-axis. It's counting the number of whatever this is. Number of people. It's not really people. It's probably flights, right? Air flights, number of flights, students, or maybe these are the number of people who are flying this way. Maybe that's what it is, right? There's students for people, there's students who are flying, there's private, commercial, transport, whatever. Whatever this means, it doesn't matter. This is the result that you're going to get. You're going to get your categories, and then these numbers here are going to show up as the height of each of these bars, the frequency. So this is a frequency. So it's similar to a histogram, but the denominator, or excuse me, the x-axis are categories, and they're not a numerical variable. All right? They're actual nominal values here, nominal values. Now, what did the histogram do? It took our numerical value and we created categories based off the numerical value, right? So they're categories too, but that's ordinal, right? Ordinal, more than ordinal. This is nominal. Okay. Any questions about a bar chart? Pretty simple, I think. Yeah. You just have to remember when you, again, let's just do it one more time. When you go to bar chart, you need to, if you do have a chart like this, then make sure you choose values from a table as opposed to counts of unique values. All right? Values from the table. Most likely going to be that. All right, pie charts. You've all seen pie charts over and over again, right? Pie charts. Now, we're using a different Excel spreadsheet for this one. And Han, which one was this? Can you see it? What the Excel function?
Yeah, it's the HDEP.
Yes.
Home Depot.
Home Depot. So these are different different product lines, I guess, from Home Depot and what their sales were. Okay, again, this is in chart form, right? In chart form. Mm-hmm. So what we want to do is, with a pie chart, we want to create a circle like a pizza pie, where we can tell the relative size of the, in this case, the sale, relative size of the scales, and these are the four categories. How many categories? Four categories. 1, 2, 3, 4. Sometimes now the settings of if you run your at least in the PC version, if you run your cursor over each of these pie segments, it gives you the actual percentage of total sales for that segment. This is the plumbing one, right? Plumbing, electricity, electrical, and kitchen, 31%. So if you took this number here and divided by the total sales, you get a percent, right?
Mm-hmm.
Yeah. How does this drawn? And they tell you in the book. Well, we know that a circle has 360 degrees, right? The whole circle, internal angle of the circle is 360. And you take the 31%, 0.31, and multiply it by 360 degrees, And that gives you the number of degrees of the central angle for this blue. All right, that's how they do it. Same thing with the red, the red here, which is hardware and seasonal value. That's 28%. So if you took your calculator and simply multiplied, in this case, 360 times 0.28, you get the angle here, this internal angle, central angle. Same thing with building materials and lumber. That's 22.3%, and then the green is 18.7%. That's the paints, flooring. That's how the program creates the circle. All right. Unfortunately, you don't have to do that because you would need some sort of protractor or something to create your circle, right? Compass and protractor, whatever. So this is not a geometry class, but if I asked you calculate it, you could, right? 360 times the percentage, you could come up with that. All right, I don't see any reason to do that, but the book kind of goes through that also. All right, so this is used for categorical data also, right? Because each of these segments are the categories of the 4 categories. So it's basically the proportion of total sales in this case, each of these segments. Not much more to say about pie charts, but if you go to pie chart, I'm pretty sure it probably has a way of well, again, it says chart values from a table, right? That's a choice here. The categorical variable. Now, in the Mac version, I don't know, do they call it categorical variable for the pie chart?
They call it, oops, hit the wrong button, sorry.
Yes.
Categorical variable, yeah. And then summary variables, and then you can have group variables too.
Right, grouping. Now, they don't mention that here, but it's possible under pie options. Nope, not here. Maybe multiple graphs might have it. By variables, here we go. That's the grouping. So for Han, if you wanted to do if there was a grouping variable, you wanted to compare different groups, right? Maybe 2 different stores. You want to compare.
Actually, if you click the data options, you can find the group options.
Yeah, but it doesn't tell you what they are.
Oh, okay.
No, it doesn't give you the actual options. So if you wanted, I think if you do multiple graphs and do the by variables, you actually choose. If there was a third, let's say there was a third variable here called store, all right? And maybe there was 3 different stores. Then you could group by store. Now, obviously, they're not going to put it in this format here, right? They would probably have had the sales for each store in the table. All right, anyway. Any questions about that? So these are easy. I mean, in most, I would say in most statistic classes, because we're not using the software, typically the bar chart and the pie chart aren't even part of the curriculum. They don't even mention it, but I don't know, you see them so often, you might as well have them part of the curriculum, right? So I'm showing it to you, and you guys can create them too. Now here's the next part is actually important actually for this course. Maybe not so much in other introductory statistics courses, might be more of a second semester. And it's called tabulation, tabulated statistics. All right. Now, this is an example. And this program is not really great, I mean, in doing this. And I think you're not going to have many options in the Mac version, but basically, a tabulated table is one where you have one, two, or even three categories, and then you have a count within each of those categories. All right, typically a count. So let me tell you how that works. Let's get to the actual. Here we go. This is the data set here, and this is one is what is this called, Han? Is this the ATM?
ATM.
ATM. Right. All right. So, what are the categories? Well, there's an age category and a gender category. The age category goes, how many values are in the age category? How do we actually figure out what the values are here for this? Anybody know? Anybody have any idea of how to figure that out from the Minitab Quick Start? In other words, how many different values, instead of scrolling down, could you be able to figure it out? If we went to data and worksheet
table information, worksheet information.
Worksheet information, right. So let's try it. Well, it's only giving us the count for each of these, right? So that's not going to help.
Yeah.
Maybe if we went to stat and did display descriptive statistics, would that help? Or is there something else that would help? Anybody remember about this? Let's try it. Let's try age category. And let's see, let's click OK and see what we end up with. Minimum value 1 and maximum value 3. I guess it's 1, 2, and 3, right? That sort of helps, right? There was something else. Wasn't there something else that would give you the information about the data set besides worksheet information? That didn't give us anything, right? Didn't help. Anything else here?
What else do I remember? There was recode.
Recode, yeah.
I don't know how helpful that would be.
Yeah. Yeah, recode was, yeah, you want to see recode? Let's try it. See if that makes any. It was numeric. These were numeric values. So let's see. And let's just look at age category, see if we choose that. We're not going to, of course, change anything, right? There they are. So you're right. Here's a way of finding the current values, is through recode. Now again, this program is very clunky. It's very other programs that are out there, like I use Stata. Stata, there's a command that gives you what we're looking for. I mean, you just type in the command, type in the variable, and it will just give you all the different values and all of that. So this is sort of a backdoor way of finding the values, is through recode. You're absolutely right. Gender, it's just going to be 1 and 2 in this case here. And then seconds is just the a time variable here. All right, so we know that age goes from 1 to 3, gender is 1 to 2. And so we want to have a tabulated statistics. And how do we get that? We go to stat. So this is a chart instead of a graph. And we go down to tables. And if we want just a pure tabulation, the tabulated table, we go down to cross tabulation and chi-square. The chi-square, don't worry about it. That's more of a stat 2 thing that we would do. And then we put one of the variables is going to be the rows, right? So in this case here, C1 represents the age category. So one of these is going to be rows. The other one's going to be columns, okay? So in this case, they want us to use age category for the rows and gender for the columns. And then we want the checkoff counts here. So it'll actually give us the frequencies. And those will go through the data set and find, for example, how many, let's assume, and let's just make an assumption here. Let's say the age categories is 3 of them. Let's say it's 20 to 29, 30 to 39, 40 to 49. All right, let's just assume those are the 3 age categories. And 1 is female and 2 is male. Okay? So this 7 here represents the number of observations or rows where the people were 20 to 29 in age and were females. All right, so females ages 20 to 29, there are 7 of those. 1 and 2, so row 1, column 2, would be the number of males ages 20 to 29, and there's 10 of those. Like that, and that's how you do this. You just go down. The next row would be age, so row 2, column 1 would be the number of females ages 30 to 39, 13 of those. Row 2, column 2, that's where the 8 is here. That's the number of males that are ages 30 to 39. Okay, does that make sense? How it works? And then these totals here, what are these totals here? These are called, these 6 numbers that are here in the middle, they're called joint values. Joint meaning they're combining 2 different categories together. All right, joint. The numbers that are along here where it says all and all here, these are marginal totals. Marginal. So for example, 17 here is for row 1. So that's all the people who are 20 to 29. There's 17 in total. There's 21 of them that are 30 to 39, 12 that are 40 to 49. The columns, remember the columns have to do with what? Gender. 1 is the female. There's 28 females, there's 22 males. They're marginal totals. So in statistics, many times we'll do this a little bit later, we can come up with, if this was a sample, some sort of survey, we can come up with estimated probabilities based off of this for the whole population. All right? So if we assume that this represents the population, then we can come up with probabilities. And we'll do that later. We're not doing it right now. We haven't learned probability yet. So this is called, now, many times instead of having 1 and 2 here, they'll actually write out the actual value. So this would be maybe female would be written here and male here. And this would be 20 to 29, 30 to 39, 40 to 49 with the word age next to it. So it's more explicit, right? Because 1, 2, and 3, 1 and 1, 2 here, you know, you can easily get that confused with whatever. So you definitely better to put names here for the categories instead of numbers. And I believe you can do that with options. Options you could probably I don't know. Well, they should give you the ability to write in the names for these things, these labels. But it doesn't look like they're giving that to you here. As I said, this is not a great program. This is really clunky and not very sophisticated. So other programs that give you the options where you can rename these values here. All right. Any questions about what cross-tabulated table is? It's basically the categories, and you're just counting the number of people in the data set that meet those categories. All right. So, all right. This next one, it's a cell summary. It's the same thing. It's the same thing, except we're going to get something that looks like this, except we're going to get also some summary statistic for each of those categories. So ages 20 to 29 that are female, we can get something like the mean of all those, the mean of the time here, the ATM time here. The mean, we can get that displayed also just for that group. All right, because how many groups? We have 6 groups, right? There's 6 groups here. So how do you get that? And this is what it's going to look like. We go to, and it's the same data set, of course. We go to stat, tables, and this time we're going to get down to descriptive statistics. Okay. And what do? Well, again, we put our rows in, the row category, the column category. And then we could go down to associated variables. Associated variables. What is the associated variable? It's typically the quantitative variable here, right? And what we want to do, what we can do is we can find any of these summary statistics of that quantitative variable for that group, just for that group. You can have the mean, you can find the mean of for that. For example, this one right here, there's 7 people who have ages 20 to 29 that are female. And if we took the mean of those 7 times for those 7 people, we get 39.27. Okay. Then for males that are ages 20 to 29, there's 10 of those. We took the mean of those of the time. We get 37.41 seconds. It also does it for the marginal totals too. It'll take all 17 of them, all 17 people who are ages 20 to 29, and takes the mean of those 17 numbers, and it's 38.18. All right, and it does it for all of these, and then it does the same thing for the columns too. So for females, there's 28 females. This is the mean for the 28. This is the 22 males. This is the mean for them, and this is the mean for the whole thing, the whole group, all 50 of them. And you can do it for, you don't need a mean, right? Actually, can you display more than one? Yeah. So, I mean, it's going to get kind of sloppy looking, but you can display the mean. We haven't covered the standard deviation yet, but we could cover that too. We could have both of those numbers being displayed. We could have maximum, minimum values for the grouping, things like that. So this whole, you're going to have the sum of all those numbers, all those values in each group. So is that clear how that works? And then when we click OK and OK again, we end up with something that looks like this. So it's exactly the same as before, except it's giving you a descriptive statistic for that group along with the count. 7 people who are females ages 20 to 29, and their average, the mean time for that group of 7 is 39.27 seconds. And that's how you read it. All right, any questions? Pretty straightforward? It's not straightforward? Okay, so it's okay. I just want to make sure you're all 3 of you okay? All right. And that's it. That's chapter 2. That's what you're responsible for chapter 2 are those, what is it? 1, 2, 3, 4, 5, 6, 7. There's 7 of these graphs and charts. And that's it. So what you've seen today is what you're responsible for in chapter 2. So what I'm going to do, and give me a couple days to do this, but I'll have it done by Saturday, is I'll give you some homework from the chapter 2 for each one of these things. All right, I'll find ones that you can do. Now they may involve entering data instead of downloading data, or downloading a data set. All right, so you should have some practice entering data, but entering data is very easy. You just, and on this row here, you just type in your column name, and then you just simply type in the numbers or names right in here. Just type it right in. All right, so it's pretty easy to create a data set, and then you can save it. All right, so I'll give you the that homework, and give you some practice, and then sometime soon we'll have some sort of quiz also. I'll let you know. I was promising you a schedule, so I'll come up with a schedule very soon with when the first quiz and the first test is and all of that, and the project. Now that I know what you are capable of doing, at least for chapter 2 in terms of Minitab, I can give you also a project to do with a data set. All right, and that would be the first project also. Very straightforward, very easy, nothing complicated. You will always have in front of you your notes, your book, your software, calculator, whatever. All right, so everything's going to be open. Whenever I give you anything to do, you have everything in front of you to do it. However, if it's a quiz or a test, it will be, once you start, it will be timed. So make sure you're familiar with where everything is before you sit down and take the quiz and test. All right. Any questions? Okay. So stop sharing. And that's it. So what I'll do is I'm going to post it. Once I get this recording complete, I will post it sometime tomorrow. Have it posted for you. I've already posted the recording from Tuesday. Just posted it tonight. And it takes a little while for it to convert into the proper format for posting. And then it'll be available for you to review again. And then, as I said, by Saturday, I'll have the homework for you to practice all this with. And then the schedule too. I'll work on that so you'll know the schedule for the quizzes and tests that are coming up. All right? Any questions? Everybody's okay with it, what we've done so far? Yes? Okay.
Mm-hmm.
All right, good. So that's it. Any questions? No questions? We're good? We can go?
Yeah.
Yeah, yeah. So I think I'm okay myself for tonight. I was wondering if I was going to be able to do this pain-free, but didn't even notice my pain at all tonight, so I'm okay. So
Good.
yeah, so I'm good. All right, so that's it. And so send me any emails that you have, any questions, whatever. And again, for those of you, I guess Han and Steve, you've already sent me the preliminary, that quick start files, right? Mo, you have not yet, right? Or did you?
I did not, but I thought that because of the limitations of the Apple Minitab, that it wouldn't count towards the extra credit.
All right, that's fine. You don't have to do it. All right, so I'm not penalizing anyone for not doing it. I'm just saying if anybody wanted to do it or could do it and wanted some extra credit, that would be all right. But I'm not going to penalize you for not being able to do it. So, are you okay? You're okay with that?
Yeah.
Okay. Just want to make sure. All right. So that's it. So I will see you next Tuesday. At
Okay.
and I think is 8:30 work well for you for Tuesdays and 7:45 for Thursdays? Can we just be consistent about that? Okay.
Sure.
That works well better with my schedule. So let's go with that for now. All right. Good. So I'll see you at 8:30 on next Tuesday.
Okay.
All right. Have a good night.
Bye,
You
Professor.
too.
Okay. Bye-bye.